Nuclear fission. On the left, sometimes the explosion does what we expect. On the right, Chernobyl is where it all went wrong. The Argus 500 watched the explosions, prevented the disasters, and was a Cold War secret. Hello, my name's Malcolm Clark, and I worked for Ferranti from 1971 until its demise in 1989. I then continued maintaining the Argus 500 range of computers until 2002. I've been a volunteer here at the museum since the end of 2019. Today, I'm going to talk about the Ferranti company, the Argus 500 computer in general, its worldwide use in industry and beyond, how this machine fits into our collection in the Large Systems Gallery. Then next I'll be talking a little bit about the history of the machine, and then its acquisition. The main part of the talk then will be about the restoration, and I'll be handing around some of these pieces from the display so you can just have a look and have a feel. Finally, I'll look at the future and some ideas of what we can do to educate, engage and inform the public with the machine. So, a new working exhibit. In 1882, Sebastian Ziani de Ferranti set up a business in London designing various electrical devices and making his Corliss dynamo and mercury meter. He supported Nikola Tesla in the War of the Currents, which was the AC-DC debate. In 1949, the computer group was formed. Ferranti joined with various university-based research groups to develop computers. The first effort was the Ferranti Mark I, with about 9 delivered between 1951 and 1957. In 1963, the computer department was sold to International Computers and Tabulators Limited, which later became ICL and Fujitsu today. The deal with ICT excluded Ferranti from the commercial sector, but left the industrial and military fields free. Then we get to 1968, when the Argus 500 came into the industry. This lasted for about 10 years, when it was replaced by the Argus 700 in 1978. There are still Argus 500s and Argus 700s in use today. In 1987, Ferranti purchased International Signals and Controls, a Pennsylvania-based defence contractor, and was renamed Ferranti International plc. Unfortunately, this was a fraudulent company and led to Ferranti being broken up and going bankrupt in 1993. So Dungeness nuclear power station. This power station was the first pair of advanced gas-cooled reactors and commenced construction in 1965. By 1968, the Argus 500 was chosen as the main control computer for both reactors, with a live spare machine switchable to support either processor. Due to construction delays and financial problems, the first reactor did not come online until 1983. With the second starting up 2 years later. They were both shut down in 2021 due to boiler corrosion within the reactor. Argus 500s were also installed in Hartlepool and Heysham nuclear power stations, both coming online in 1983 and 84. These are still operational today. One central processor, the processor and store, however, was upgraded by Ferranti with an Argus 700V system, which ran an Argus 500 emulator. So the machines themselves and the whole installation is still exactly the same, the software is exactly the same, running 4 nuclear reactors today. So, the Argus 500. It was first produced in '68 in Wythenshawe in Manchester. It uses integrated circuits, as you can see over there, and had considerably more computing power than its early Ferranti machines. This was mainly due to it having a 24-bit parallel arithmetic logic unit. It was aimed at major industrial applications for direct digital control and was easily customised for a wide range of environments. So, what was it used for? Here are just some of the places that the Argus 500 was used. In industry, we could start with nuclear power stations at Dungeness, Hartlepool and Heysham. The CGB bought Argus 500 to run the national grid from behind Bankside Power Station, which is now Tate Modern. North Sea Oil. When Queen Elizabeth II pushed the button to start North Sea oil flowing, the Argus 500 was controlling the pipeline network. Oil refining was a major user, Esso Forley, Mobil Corriton and BP Baglin Bay, just to name a few. It ran a wide range of continuous process, making biscuits in Harlesden, cement, chemicals, made every inch of 35mm film in Kodak, and was responsible for rolling steel in South Wales. In terms of research, Post Office Martlesham used an Argus 500 to develop machines to read postcodes in the early days. The RAE in Farnborough had an Argus 500 controlling a massive pressurised wind tunnel. Boeing used this to develop the winglets at the end of the wings. They brought models in, put them in the wind tunnel, and the Argus controlled the environment and temperature, pressure and wind speed so that they could scale down the model and get the use the same equations that they would use on a full skies aeroplane. It was chosen by a few customers to retrieve data from mass spectrometer. It seemed to be one of the key things in those days. This was pretty difficult in the late 1960s due to the high data capture rate needed. CERN in Geneva bought a couple of machines to control their intersecting storage rings and run some of their interactive displays. In terms of government and military, Birmingham and Strathclyde police forces used it for command and control of incidents. The Home Office in London researched digital fingerprint records. The CAA Heathrow and Australia Department of Civil Aviation used Argus 500 as a message switcher for routing flight plans around the world. Some of the parts we have come from CAA via Dungeness. The UK AEA at Aldermaston researched the nuclear pulse, the electromagnetic pulse you get from a nuclear explosion, which is one way it watched the nuclear explosions around the world. The RAF used the Argus 500 for a secure communications network during the Cold War. And there was also a telegraphic automatic routing equipment called TARES project for the Defence Communications Network and the Operational Teleprinter Network. Dungeness bought the TARES system and a lot of the documentation as spares for their site. So we have some of the TARES equipment here as part of our spares. The Bloodhound Mark II missile, I don't know if anybody has been involved with that. It's part of our air defences during the Cold War. It's first used the Argus 200, then the Argus 500 as its launch control system. Its last upgrade was to an Argus 700, and this has been fully restored by the Bloodhound Missile Preservation Group. It's on display in the Radar Museum in Neatishead. The Australian Navy bought 7 Argus 500s for training simulators. Our Royal Navy already had Argus 400 simulators for surface, underwater training systems. As I said earlier, there are records of around 200 Argus 500 deliveries, but the records I've seen are incomplete, so there may have been more than that. So that's a bit about the background of the machine and where it came from. So where does it fit? This is kind of a bit of a snapshot of the Large Systems Gallery. We start with the Marconi TAC, manufactured around 1958. Logic elements were made from germanium transistors. It's a serial arithmetic logic unit, and it has 4K by 20 bits. That's approximately 10 kilobytes, but for that machine we don't tend to refer to it in bytes because it's a 20-bit machine. Then there's the LEO 803B, manufactured around 1962. Logic elements made from germanium transistors and ferrite cores. Again, a serial arithmetic logic unit. This has 8K by 39 bits. Core store again, and approximately 40 kilobytes. The Argus 500, manufactured around 1968. Logic elements are silicon integrated circuits. They are Ferranti Micronor 2, and there are two versions. The left-hand one that's laying down is 8-leg cans, and the one standing up is 14-pin dills. But all the ICs were made by Ferranti in their own fabrication plant in Gem Mill in Manchester. It has the parallel arithmetic logic unit. We've acquired all the circuit diagrams. That large diagram there is part of the adder in the middle of the logic, and it shows some of the logic needed to predict the carry as you count up across the parallel bits. For Dungeness, was equipped with 32K by 24 bits. This is one of the cores, which I've opened up for you to have a look at. So that was 96 kilobytes, but the Argus could take twice that. Finally, in the LSG, amongst the larger systems, is the 2966, manufactured around 1984. This has logic elements of TTL and ECL in the processor, and it has 2 megabytes by 32K, 2 megabits by 32-bit of dynamic RAM. So that's approximately 8 megabytes of store. So it fills in a bit of a gap between the 803 and the 2966 and shows stages in technology. Again, all British-made computing. So, Dungeness and the acquisition. That's Dungeness Power Station. Thank you to Steve Kay for the photo. It's actually Dungeness B is hiding here behind Dungeness A. So the Argus 500 system had been completely replaced in Dungeness, and the main equipment stripped out and sent to Hartlepool and Heysham as spares for their live systems. Daisy, which is the name of our machine, remained as a standalone machine and had been retained in an operational state with the intention of being donated. The site visit was performed by Peter Vaughan, Colin Eby and Steve Kay in 2017, and a few others, to strip down the machine and divide it into 3 separate 19-inch racks. This was so you could get it out of the building security gates. Here's a picture of the main system in the control room at Dungeness. Dungeness had gathered additional spare processors and core stores from around the globe to support their live system. As one failed, they would just replace it, as there was no longer anyone offering a repair service. This was caused by the government wanting to extend the life of nuclear power stations because of their green energy. So all nuclear power stations had 10 years and then another 2 years, and in fact, Hartlepool and Heysham have just had some more years added to their life. And unfortunately, they're running out of people because everybody's retiring. So yes, Dungeness went around the world looking for things. We were given the remaining working items and all the faulty ones too. However, we're not given any of the third-party add-ons to the system, because as the machine aged, some parts were just not repairable and they'd been replaced and new parts built in. But all of those are now in use in Hartlepool and Heysham, so they wouldn't give us any of those spares. It meant that we had some holes in the collection, things that were originally supplied by Ferranti that we no longer could replicate. This included the peripheral interfaces and some special tape reader interface for the paperless tape PC, which you'll see on the machine when we go around the gallery. Some of the parts originated from the RAF, from the TARES project, and from CAA Heathrow. And from Australia, they'd found 2 semiconductor replacements for the core stores, which we have here. This is the replacement, which was designed by Ferranti in Australia when they had real problems getting the core stores replaced. But we have 2 of those, and that's given us a really good storage for the future. And that's much more easy to maintain. We've got all the drawings as well. So that was really good acquisition. So all the items were photographed, logged on collective access, then put to bed in the store in Bilton Road. So moving on to the restoration. 19th of November, 2019 November, sorry. This was the start of my involvement. I spotted that TNMOC had an Argus 500 monitor panel. In fact, that monitor panel we can see on the table. First, I became a supporter and then a volunteer, hoping to be able to restore the machine. COVID arrived, put everything on hold. So, from January 21 to about April 21, we did the majority of the rebuilding. This is what the machine looked like on the pallet. 2 bays separated, wires everywhere. The faulty monitor panel was shipped to me because there's a label on it saying it was faulty. So I cleaned it in my home and found the wire that was missing. So somebody had replaced the switches in the past and they hadn't soldered one of the connections, and over the time the wire had jumped off. So that was an easy repair. Between February and April 2021, a major decision was made. This machine came as 3 bays. We haven't shown you the 3rd bay. And it was decided that because of the space restrictions in the museum and the amount of equipment that we needed to put in it, we only needed 2 bays. So it was decided to cut the machine down to just 2 bays and do a restoration on those grounds. The racks were bolted back together and a mass of interface A cables were reconnected and re-terminated. This was all completed in the corridor space in Bilton Road. There was no workshop at that time. After each visit, it was back on the pallet truck and back in the racking. Peter Vaughan, who's with us today, searched through the Dungeness documentation and found a circuit to interface the PC to the Argus. He made a test cable ready to load programs for the PC when we were ready. So this is what it looked like when we had it. On the left, there's a tangle of wires draped where the processor should be. Those are the cables that connect to the monitor panel. At the top right, you can see a pile of processors and stores stacked up on the pallets. Also, there's a power unit there, and just about see the plinth tucked between the pallets. At the bottom, there's the massive interface A, twisted triple wires that needed to be reconnected. Luckily, Ferranti had marked them with coloured labels. And in my toolbox, I had the special tool to push them back in with. So, that's what we were presented with. We managed to, it took till August to get the machine in a state to switch it on for the very first time in over 4 years. As expected, initial testing showed that over 50% of the processors were faulty. So here we are. Top left is me struggling with the wires, removing the information. I had to remove the termination block from the 3rd bay that we were throwing away and install it in the 2nd bay underneath the original. In the centre, you can see that all the wires are complete. The bottom is actually at the point we first switched it on and made it do something. That is actually just doing a binary count from an instruction set on the hand keys. The picture on the right is me trying to put in a program for the first time. So, I'll just show you what happened.
And here we have the first that manually entered a program from none other than Malcolm. Perhaps I shouldn't say it's taken us an hour to do it.
But we have found our faulty code.
I've gone through 3 processors and 2 core stores, yeah. But we have now actually have our first running program.
Name shifter. All it does is take 24 bits of ones and shift it round into the double length Q register and bring it back again, just so you get that sliding pattern and you can change it from the hand keys. So it's fairly simple, but it was done 1 bit at a time on the hand keys. So over the next months, we moved into the new Bilton Road workshop. We connected up the PC interface to load test programs. completed more tests on processors and core stores, wrote some more simple programs, and we made a restoration video in February 22, which you can all view on YouTube. And we also located more spares and some of the vital documentation. So we had the machine running, but we were short of some key parts. So we looked out to try and find some other things. We invited to Hartlepool Power Station. Peter and I visited Hartlepool Power Station to collect parts that they no longer needed. Importantly, this included a Ferranti serial interface card, a spare power unit, and some more processors and stores. We had a brilliant day and were given a VIP tour of the computer room and a walk around the control room of the live nuclear plant. For the long-term support of the exhibit, we needed to be able to repair the processors. The stores were not so much of a problem as we had the Australian semiconductor replacements and all their drawings. Thales came to the rescue, Thales in Stockport. I made contact with some old colleagues who were still supporting the Argus 700s at Dungeness. They'd recently decommissioned all their Argus 500 test facilities and moved offices. They were happy to donate their logic diagrams and test equipment, plus some other unspecified parts. We first visited Thales in April 23. We were taken to a damp container in the car park, packed with all sorts of Ferranti Argus 500 and 700 parts. After much sorting, we came away with a couple of stores and processors in large wooden crates. You can see the crates here. We were also given the precious logic diagrams and signal listings for the Argus 500 processor, which are also over on the table, which you can look at. On the second visit to Thales, we were taken to the same container, which had been emptied and restocked with more Ferranti parts. Unfortunately, there'd been a mishap in the store, and most of the items were severely damaged. It looked like they'd been dropped off the pallet. Luckily, the test bench that we were interested in wasn't too bad, and we were able to rescue 3 original Ferranti paper tape readers too. So, there we are on the top left, a proud picture in Hartlepool. That's the only, they would take a picture. We weren't allowed to take cameras or phones in. They had to sign them in as we went in the door. That's the only picture they would release. They took other pictures of us near the panels and near the monitor panel. No, that's the only one they'd let us have. That's a live nuclear power station. Below is the test rig as it's coming together at Bilton Road. It's seen many, many years of use, and it's just taking a little bit of time to get it back in one piece, let alone switch it on and make it work. But what it does, it opens up the stores and processors so you can get to that logic on the processor while it's actually running, which you can't do in a normal machine. This tape reader, it looks rather battered and mouldy. I've restored that as well. That's in the museum. At the top, that cable is a new serial interface cable which we had to make. We got these serial cards from Hartlepool. So this was gold dust really, because it allows us to talk to the outside world from inside the machine. We just connected it up to a VT220 terminal and ran the store test. And that's what we're running at the moment around at the machine today. And finally, we have a few stores and processors. Unfortunately, there's a predominance of red labels for the ones that don't work. We do have 3 working processors. So one's in the machine today, and there's still a couple down at Bilton Road. So, where are we today? There is the machine which arrived in the museum on the 10th of March, just 3 weeks ago. The logic diagrams have been digitised and verified, so now we have an electronic copy of them, which allows us to blow them up large so you can actually see how they work and work out where all the signals go. The tape readers have been repaired and tested. There are two types, one on the machine at the moment and another one on the table there. Hopefully we'll be able to get visitors to load paper tapes. We've also got a box of original test tapes there, which we can copy and use. And the test bench is under construction in the workshop. So what are we going to do in the future? Well, there are three main areas to work on: hardware, software, and ongoing support. So in terms of hardware, we want to wire up as many of the interface cards we have, including a second serial card, an interrupt timer, so we can make a clock, some digital input and output cards we can borrow from the Argus 700, which we've taken away to Bilton Road. They were in fact Argus 500 cards modified to work in an Argus 700. So we'll take the modification off and we'll give them an outing in the 500. Perhaps we could build a Raspberry Pi replacement for the paper tape PC like Peter Onion has for the 803. That would be much more repairable and much easier to maintain than the old industrial PC that came with the machine from Dungeness. Maybe we could find and build a backing store. We've got no hard disk interface or hard disk physically. The machine would have had 2 megabyte large Burroughs disks in its original state, but none of that exists anymore. In terms of software, we can start comparing the Argus 500 to the other machines in the museum. Maybe calculate times tables on the Collette's conjecture. Maybe prime numbers, and to see how quickly it generates prime numbers. Currently the 903 is producing prime numbers, which you can go and watch and see it doing that. Be interesting to compare the speeds of the machines. We could do squaring numbers, which is what the Witch does most of the day. We could, if we get the digital inputs and outputs working, we could get the Simon Says game going, the same as on the 803. Maybe the Fibonacci series and see how the maths works. So we could either make those on paper tape. Jerry McCarthy has written an emulator for the Argus 500, a simple emulator, so he can write programs at home. And hopefully he's going to be in tomorrow to try some of those out. We can look into the original operating software. Of course, didn't get any software with the machine, but we have discovered that the source listings were on a DEC PDP 1185 that we also acquired at the time of this machine. But we've not been able to unscramble how that worked and get that out yet. So there's another software angle. We could also perhaps try and find an original Argus operating system, which in the last one in the range was Director 7, and that would allow us to program in Fortran, which was the language of the time. In terms of ongoing support, the jobs is to core stores will fail and can be swapped around and ultimately replaced by the RAM store module, which is much more repairable. But for the processor, we now have the diagrams and the test gear. Components can be sourced by scrapping some of the existing faulty items, and we've got plenty of those. This is a great opportunity for anyone to really understand how a digital computer processor works and dig into the diagrams and repair some of these things. We could build new hardware based on Raspberry Pi for doing some of these jobs, and maybe link the machine to a power station emulator and the TAC, which also was from a nuclear power station environment. So, finally, as a summary, the Argus 500 was decommissioned from Dungeness in 2017, donated by EDF Energy. Restoration started in 21, and it took till 2025 to move it to the Large Systems Gallery, where it is today. We've got our test software, the ability to run simple programs, loaded from paper tape or a PC. We plan to install as many original Ferranti parts that we can. This is the only working Argus 500 left in the world. It's unique. This claim as being the only one left is based on testimony from the employees at Dungeness that scoured the word for their spares. and also talking to Thales, who were the last people to ever repair an Argus 500 processor. However, there are, as I said earlier, still 2 Argus 500 installations running, Hartlepool and Heysham Power Station. These had their processor and stores replaced by the Argus 700V. But they will be end of life in the next couple of years. So maybe there's more spares that we can get from them when they decommission. But they will use the machines to defuel the reactors. So that will take a few years to do as well. So finally, as I said, we did a video. Thank you, Dave, for the video we did in 2022. That's freely available on YouTube for you to go and see. It explains a bit more about the early restoration and some of the things we've been doing. So that concludes my presentations. Have you got any questions? If we can wait for the microphone. Yeah.
Hello, yes, I was wondering if you were in touch with any of the people maintaining the units at these working power stations. I may be mistaken, but I think one of them is a reasonably active contributor on the VC-Fed forums.
We have made contact with the people at Hartlepool, but none of the other power stations.
Excellent presentation, thank you very much. When I arrived at West Drayton, the London Air Traffic Control Centre in 1971, there was an Argus 500 there, which they'd been attempting to get to work as a flight plan and radar data processing system. It wasn't quite man enough for that because during the 70s, air traffic control was increasing out of all recognition. But it's very interesting to note that the Argus did actually get used for more than just the message switch at Heathrow. There was also one at West Drayton, and for a while it was actually running flight and radar data processing for en route air traffic control.
Yes. It's a very versatile machine. Corner this, Dave?
Who is it that chap with the hand here? Sorry, just give you the microphone there.
Thank you. I'm sorry, I don't know if the microphone's working, but sorry I'm late today. Thank you for the presentation. I'm a big fan of the nuclear power stations that you've been talking about in the past, and I've been to a few of them. I mean, what were the computers actually doing there? I mean, were they still controlling them as well when they came out?
Yes, it's a complete control system of the whole plant, from the control rods in the reactor to the boilers, to the pressure for the pumps, the complete control system, both primary and secondary. It was described at Hartlepool, they said about what the computer did. They'd got to a point where you can run the nuclear power station manually, but it's really difficult. So if the computer failed completely, they would shut the power station down because all the variables within the environment, you just couldn't do it manually. It was described that the Argus would take the control rods and it would just adjust them like this all the time, just to keep things balanced. So as the load changed, as the weather changed outside, the temperature of the sea changed, the load changed, it would just keep the whole thing in balance. Each of the cells in these nuclear power stations is 632 degrees of compressed CO2, and that's how they work. And so it controls that temperature by adjusting control rods, and then there's a heat exchanger which takes it out to the boilers. And they adjust, the major set point is the pump between the two. So if they want more power out, they turn up the rate they're drawing heat off, and the control rods then rise to make the reactor give more power out. So that was interesting to learn how it actually works in terms of principle. But it's all the screens with all the different cores on, all the different temperatures in, and all coming out of the Argus installation with the Argus 700 emulating the software.
Plus all the monitors and
Yeah.
or whatever
Yeah.
associated with it.
Yeah. So there's big sets of displays and everything that's going on. So that, it's the same principle that if the main processor for one of the reactors failed, the spare one sitting between them would switch to it and take over straight away as a bumpless transfer, so that it would keep running the reactor. And engineers would come in and switch things around and get it back working again. Okay. Thank you very much. Well, there's one more there.
Thank you. I'm very interested in sort of ancient history of computers. You put the Ferranti sort of life cycle there. Where did Leo fit in?
I'm not sure where Leo fitted in. I'm sure we can find out exactly where Leo fitted into that timeline. Okay. Thank you very much.
Thank you.
I think it's